You're looking at a $6 paint bucket. In the next 14 minutes, this thing is going to spin fast enough to charge a phone with 0 wind turbine parts inside it. Last year, the average American sat in the dark for 11 hours, almost double the decade before. And every single time the power goes out, the same handful of backup power companies raise their prices right when you need them most. Here's the part they don't put in the headline. The design hiding inside this bucket is almost 100 years old, built by an engineer the wind industry has quietly buried for decades. So how does a paint bucket outperform an $800 generator? And why has this been sitting in plain sight the whole time? Quick question before we start. Comment the word spin if you think a $6 bucket could actually generate real electricity. Comment the word doubt if you think I'm about to waste your next 14 minutes. I want to see where you land before you watch the proof. Here's the question nobody in the backup power industry wants you asking. Why does the price of a generator jump the moment a hurricane warning hits the news? This isn't a conspiracy. It's simpler than that, and honestly, more frustrating. The backup power industry doesn't price based on what something costs to build. It prices based on how scared you are the week a storm is coming. Think about it. A generator that sells for $600 in a calm month can jump to $900 or $1,000 the same week a hurricane is forecast, purely because demand spikes and supply doesn't. That's not manufacturing cost going up. That's fear being priced into the tag. Retailers call it seasonal demand pricing. Everyone else just calls it paying more because you're desperate. Meanwhile, the outages keep getting worse, which means that fear premium keeps getting more profitable. According to the Energy Information Administration, the average American customer experienced 11 hours without power in 2024, nearly double the yearly average of the previous decade. Texas alone recorded over 200 weather-related power outages between 2000 and 2023, more than any other state in the country. A design that costs $30 and doesn't need a storm warning to work doesn't fit into that pricing model at all. It's not that the industry is hiding it. It's that there's no fear premium to charge on a bucket you already own. This design has a name and a birthday. It's called a Savonius rotor, named after Finnish engineer Sigurd Savonius, who patented the concept back in the 1920s. Here's why it matters. A traditional wind turbine, the kind you see on a hillside, needs the wind blowing from one specific direction, and it needs that wind moving fast. That's a horizontal axis design. It's efficient, but it's picky about conditions. A Savonius rotor is a vertical axis design. Picture 2 curved scoops, like the 2 halves of that paint bucket, mounted opposite each other on a spinning pole. Wind hits the cupped side and pushes it. It doesn't matter if the wind comes from the north, the south, or shifts every few minutes. The rotor keeps turning because it's not chasing a direction. It's catching drag from whatever direction shows up. That's the physics. Now here's the proof. It actually generates something real. In multiple independently documented builds, hobbyists and off-grid homesteaders have clocked small Savonius rotors producing between 4 and 12 volts of output at low rotation speeds, enough to trickle charge a 12-volt battery through a basic voltage regulator. The build cost in most of these projects landed under $40, and in several documented cases, closer to $0, because nearly every part came from something already sitting in a garage or a secondhand shop. This design also shows up far beyond hobby projects. Vertical axis rotors, based on the same drag principle, have been used in low-speed, wind measurement instruments and small-scale off-grid setups for decades, precisely because they start spinning at lower wind speeds than blade-style turbines. That's not folklore. It's a design nearly a century old, verified again and again by people with nothing to sell you. Here's exactly how 4 off-grid builders turned garage scraps into a working power source. No welding certification required. Generator number 1 starts with the rotor itself. Take 2 plastic buckets, the 5-gallon kind you can grab secondhand for a few dollars each. Cut each 1.5 lengthwise using a basic utility knife or a jigsaw. Mount the 2 curved halves onto a central PVC pipe, offset from each other by a slight gap so the wind always catches at least 1 scoop no matter which way it's blowing. Secure each half with washers and bolts through the pipe wall so the whole assembly stays rigid under load. Generator number 2 is the power source, and this is where most people get surprised. An old washing machine has a motor built to spin a heavy, water-soaked drum, which means it's already engineered to handle continuous mechanical load. Pulled from a dead unit at a scrapyard or thrift store, that same motor can be run in reverse. Instead of electricity spinning the motor, wind spinning the motor now produces electricity. Total cost for a salvage motor typically runs between $20 and $40. And three-phase motors from front-load washers tend to produce more usable voltage at lower rotation speeds than older single-phase models. Generator number 3 is the connection point, a basic bridge rectifier and a small voltage regulator, both available online or at an electronics supply store for under $15 combined. This step matters because a spinning motor produces messy, inconsistent, alternating current. The rectifier converts that into direct current, and the regulator smooths it into something a battery can safely accept without overcharging. Generator number 4 is storage. A 12-volt deep cycle battery, wired through the regulator, holds what the rotor produces, so it's ready the moment your power actually goes out. A basic battery box setup, including battery, wiring, and a simple charge indicator, runs about $50 to $70 if you're starting completely from scratch, though many off-gridders already have a battery sitting around from another project. Total build cost across all 4 components, assuming you're salvaging at least the motor and the buckets, lands somewhere between $30 and $80. Compare that to an $800 gas generator that still needs fuel every single time you use it, on top of the sticker price. Mount the finished rotor on a fence post or a length of buried PVC pipe set in concrete for stability, run the wiring down to your battery box, and you have a standing source of trickle power the moment the wind picks up, sitting there whether or not a storm is in the forecast. Now, honestly, this isn't magic, and anyone telling you it replaces your power company is lying to you. A backyard Savonius rotor built from a 5-gallon bucket will not run your refrigerator. It will not power your air conditioner. The output we're talking about, 4 to 12 volts at low wind speeds, is enough to keep a phone charged, run a small fan, or power a string of LED lights during an outage. It is not a whole home solution, and treating it like one will only leave you disappointed. It also depends entirely on wind. If you live somewhere with long dead calm stretches, this system will sit idle for days at a time. That's not a flaw in the design, it's just physics. No wind, no spin, no charge. If your area averages very low wind speeds year-round, this project will underperform no matter how well you build it. This is a supplement, not a replacement. Think of it as the difference between a backup flashlight and rewiring your whole house. It buys you comfort and a little independence during the exact hours the grid usually fails you. Nothing more, nothing less. And that honesty is exactly why this design has survived 100 years, while fear-based pricing on backup power keeps climbing every storm season. Here's the part that actually matters. This technology wasn't lost. It was never marketed hard, because there was never a scarcity moment to sell it into. Sigurd Savonius wasn't trying to build a pricing model in the 1920s. He was solving a physics problem. Nearly 100 years later, that same solution still works exactly the way he designed it, using parts most people throw away without a second thought. The real lesson here isn't about wind turbines specifically. It's that understanding one basic principle: drag versus lift, cupped surface versus flat blade, can turn garbage into a genuine resource before the next fear premium ever gets the chance to charge you for peace of mind. That kind of knowledge doesn't expire, and nobody can put it behind a price tag once you actually understand it yourself. So next time the forecast says storms are coming, you've got 2 options. Wait for the outage, watch generator prices spike, and hope your phone battery lasts. Or spend an afternoon now, before the warning even hits the news, with a bucket, an old motor, and a few dollars in hardware, so the wind is already working for you before the power ever goes out. If this changed how you see the stuff sitting in your garage, subscribe, because next time, we're taking on the next industry that's been quietly pricing your peace of mind higher than it should ever cost.